Hello everyone. In this video I'm going to show you how to extract flow and velocity and temperature profile from Fluent and plot them. So let's do a Fluent flow block. Open the design modeler. So I will create a very long pipe first. Let's change the units to millimeters and go to XY plane, create in sketch. So go to sketching mode here. I'm going to create a rectangular here. So I will start from a little bit of negative and create something like this. Then go to dimensions, general. I wanna the pipe diameter to be 10 millimeters and the length of the pipe I want to be 1500 millimeters. So it's a very long tube, so I will define this end as inlet, and I want to have a fully developed flow and plot the velocity and temperature profile near the outlet here. So let's go to modeling, concept, surface from sketch, and create a 2D surface. So let's close this one and go to meshing. So this is kind of very simple simulations, but I want to show you how to plot the velocity and temperature profiles and export to a file, and then you can plot them in Excel or whatever language, whatever software you use to post-process and view your simulation results. Okay, let's define the mesh size as 1 millimeter, and I would like to have inflation layers to capture the velocity profile in a nice way. So I will select this surface as the geometry, and the boundary I would like to have these two walls as inflation layers. So I need more points, so I will do like around 20 layers. It's so you will see I will have a very fine mesh near the wall, so but we can capture more points near the wall where is the higher velocity and temperature profile. It's almost done. Okay, the meshing is done, and you can see near the wall we have a very fine mesh. If I zoom in, you can see we are trying to capture as many as points as possible. So now I will try like select these two walls, press N as a name selection. So I will say walls, and I will define this end like name selection, or N as inlet, and define this end outlet. Okay, then let's send the mesh to Fluent. So let's close the meshing and open the Fluent. Okay, now we have our mesh here. So I will turn on the energy simulation on, because I want to have a heat transfer from the walls to the fluid. I will go with the K epsilon model and realizable K epsilon with standard wall function. Okay, then I will go to materials and go to Fluent databases and go down and bring in water to my model. So we have water here, liquid water. So I will define the cell zone as liquid water. So we are defining this whole pipe to be the water. So now the inlet let's have a higher height velocity, 2 meters per second, and let's change the temperature units to Celsius. I want to have 100 Celsius. Oh, sorry. I want to have 20 Celsius or 30 Celsius inlet, and I will define the wall temperature as to be 100 Celsius. So I will do two simulations, one with the wall temperature, one with the wall heat flux, and plot the temperature profile, and you can see that the differences. Okay, let's go to initialize our system. Okay, then do around 200 iterations. It should be converged by that time. So let's do the calculations. Okay, now the calculation is done. Let's first plot the temperature counters. So if you go to beginning, you can see that thermal boundary layer is growing, and after a while 2 boundary layers will reach, and there's no, and towards the end of the pipe we have almost fully developed flow. So let's plot the temperature profiles. So I will go to plot, XY plots, then position will be in Y direction, so, and this will be 0 and this will be 1. I want to do the temperature, and I want to do the temperature on a line, so define new surface line and check mark the line. So if you remember, I started a little bit to the negative part when I was doing the pipe, so I will do the from the pipe geometries from Y. Let's change this unit to millimeters first. So lengths, okay. So the pipe was from 0 millimeters to 10 millimeters, the diameter, and I want to have a vertical line at x equals to 0. So let's do this vertical pipe D, okay, and another one to up to the mid of the pipe. So vertical pipe R. Great. Okay. So let's plot this one. You can see the very nice plot. It shows the temperature profile, and let's write this one to the file. So go to the user files, plot as this T100, okay, and plot another one. Plot another plot on half pipe Y, and the direction is in Y direction. Temperature, save plot, and this is only the half of that plot, and we can write it to the file or not, because we have all of the data, so we can check them in Excel later. So let's repeat our simulations. Okay, let's change this XY plot to vertical line pipe D and plot the velocity. Okay, so as you can see, this velocity temperature velocity profile, and let's write this to the file as, go to the user files and V100C. Okay, I want to check, make sure that we have our two temperature and velocity profiles before rerunning the simulation. So let's change the boundary condition, the wall, from 100 Celsius to heat flux. So let's do 10 to the power of 6, so 1 million watt per meter square. So let's do initialize. And let's run the calculation again. Okay, the calculation is done. So let's check the temperature counter, and you can see we have the fully developed flow towards the end of the pipe. So let's plot so the temperature profile here, and let's write it to the file. So we will do user files. Let's do T10E6Q. Okay, and let's close this one and plot number 2 velocity profile. So write this file, go to the user file, so V10E6Q. Okay, so now I will close the Fluent and open the Excel and plot these two velocity and temperature profiles and kinda compare them. So I closed the Fluent and opened an Excel sheet. So we have our temperature profile with 100 Celsius wall temperature as the boundary condition. I will copy these data, paste it to the Excel, and T equals 100C, and also I will bring for the data so it will be Q equals 10A6. These are both temperature profiles, and I will plot these. Okay, and select data, add new data set. Change the name of this series to this. Okay, so as you can see, this is for the temperature profile. The temperature profile with the constant wall temperature, and this is the temperature profile with the constant wall heat flux. If you refer to heat transfer textbooks, they mention that the gradient of the temperature profile is higher when the wall temperature is fixed rather than the wall heat flux. So this matches well with the textbooks, and we can also go to the half of the wall. This, and for this one, and you can see the temperature profile better. So in a new sheet, I will plot the velocity profiles. So we will see that what's the differences. So the first one is for t equals 100. This one is q equals to 1 million. So let's plot these two. Okay. Charge title. Let's add another one. Let's edit this one, and okay, you can see that since we defined the fluid properties independent of constant, and it's independent of temperature, so there's no difference in velocity profiles as expected. So that's it. In this video I showed you how you can export the data and plot the temperature gradients and velocity gradients or profiles. And thank you for watching this video. If you have any question, please leave some comments on this video, and if you like it, please like this video and subscribe to our channel for more videos. Thank you.